All right, let's get ready for this test. So we're taking a test on the first half of chapter 9. And it's week 10 for our online students. Okay, first thing we want to do is give the Y-intercept, the vertex, and the equation for the axis of symmetry. So that was where we were graphing, and we took the equation, we broke it down, found all the pieces, and then we were able to easily put it onto a graph. So Y-intercept is always that C value at the end. Let's see, I'll put here. Oops. Just so we remember where these letters are coming. AX squared plus BX plus C, that's the quadratic way that, and the A, B, and C are numbers. C is always the Y-intercept. So right here we can put 5. That's the quick and easy one. Vertex, to find the vertex, it's negative B over 2A. And you've got to plug in the numbers that you've got. So negative B is negative 10. 2 times, and remember there's a 1 there, not a 0. So it would look like that. 2 negatives, so now it's positive. 10 over 2 or 5. And that is our axis of symmetry and the X part of our vertex. So I'm going to put that here. We still have to find the Y value. And for axis of symmetry, we always say X equals, and it's at 5. So if we were graphing this, we would draw that vertical line for our axis of symmetry where X is 5. Okay, to find the Y part of that, where on that axis of symmetry is the vertex or the bendy part of the parabola, we have to take the 5 and plug it into the equation to see what Y pops out. So X squared, we're going to do 5 squared minus 10 times 5 plus 5. That is 25 minus 50 plus 5. Woof, negative 20. Okay, that becomes our Y value then. So that on that axis of symmetry, way down at the bottom, or way down below what we usually look at, is the vertex at negative 20. Domain. We know with parabolas, you can put any X value in there. So it's all real numbers. And with range, the bottom point, let's see, I'm going to draw it like this. So this is our parabola. And down here at 5, negative 20, that's our lowest point, like our minimum. That means that our range is everything above that, above or equal to negative 20. Okay, and I'm going to stop real quick and say, hopefully you've already worked out all these problems. You're just checking your answers at this point. Okay, or if there's one you were really stuck on, you're listening on how to do that. But don't follow along if you haven't tried the review first. That's key to being ready for the test. Number 2. Okay, we got a couple different things going on here. There's a negative sign. So this is not a smiley anymore. He's a frowny. And there's a number here in the front. So he's going to be a little bit different than some of the ones we've been looking at. Y-intercept is still the same. He crosses the y-axis at 15. Vertex, so negative b over 2a. Negative b is 24. And then 2 times negative 6 is our a value. This is an interesting one, isn't it? We have 2 negatives, so it'll end up being positive. 24 over 12, or 2. That's our axis of symmetry. So that's the X value for the vertex. And the line. If we drew that vertical line on this one, he would be at 2. So I'm going to look at this for a second. So we know he's a frowny. We know the axis of symmetry is 2. We don't know yet about the Y value. So how high does he go? Let's go ahead and plug that in then. We've got to take the X value and put them in. Negative 6 times 2 squared. 24 times 2 plus 15. Whoa. So that is 4 times a negative 24 plus 48 plus 15. 24 plus 15 looks like 39. Do we match? 39. And I'll put it here too. So the vertex, so that's way up. Normally we just kind of look at that little 5x5 grid or 10x10. So 39, he's way up there. Okay, domain, all real numbers. We can plug any x in there. Range, so this is the highest point. Everything below that works less than or equal to 39. That's our range. All right. Then on the test, they're going to ask you about maxes and mins. So it's good to remember that a negative is a frowny face. That means he has a maximum. And this one's positive, so he's a smiley. That means he would have a minimum. So we've got a max on that kind and a minimum value on that kind. To find the value, you've really got to find the vertex, which means you've got to do the negative b over 2a to find the axis of symmetry, and then plug that in to find that actual value that's the highest or the lowest. So let's do that. Negative 6 over 2. Now this is kind of tricky, right? What's our a value? Negative 1. Yeah, okay, good. Which is the negatives are going to cancel out to be positive. 6 over 2 or 3. 3 is our axis of symmetry. To get the actual point on that axis of symmetry, though, we've got to plug it back in. So negative 3 squared, 6 times 3 minus 4. That is negative 9 plus 18, so positive 9, minus 4 is 5. So this point is at 3, 5. But when we say what's the value of the maximum, we just talk about the y part. It's at y equals 5. Okay? Let's do another one. This guy's the smiley. So now we're looking for the minimum value. And we have to start with the axis of symmetry. 4 over 2 times 2. Oh, interesting. It's just negative 1. So we know that the x part of that is negative 1. Plug it in. 2 negative 1 squared. 4 times negative 1 minus 3. So what is that? 1, 2, minus 4, minus 3 equals negative 5. So that's our lowest point on this parabola. And our minimum, then we name it by the y, is negative 5. All right, let's look at this one. Use transformations to describe how the functions are related to the parent function. So what happened here? What did they do? And you guys know these things. There's a negative, so it's reflected. There's a value in the a spot, and it's bigger than 1, so stretched. And we can say by 4. The number inside the function, so it's inside the parentheses with the x, moves it left or right, opposite the sign. Negative 2 sounds like it would go left, opposite goes to the right 2. And this says up 13. That goes with the sign. Okay, number 6. We have a 1/3 in the a spot. So that's between 0 and 1. That means he's compressed, right? He's been squished down and he's fat. Plus 3 is inside the parentheses. So you should have to the left 3. And then this negative 1 down 1. So you will pick apart some transformations. All right, number 7. List the function in order from the most vertically stretched to the least vertically stretched. Okay, first of all, negative signs don't matter. That just reflects it over. It doesn't have anything to do with stretching or compressing. So when there's a negative 5, it's not less than a 4. So ignore the negative signs completely. And then what you have to do is put them in order. We're going from the most vertically stretched to the least. So we want the highest numbers. The highest numbers stretch it the tallest, which means this guy is actually the biggest. Negative 5x stretches him by a factor of 5. He is flipped over, he's reflected, but he's stretched the biggest. Then it would be, and there's a squared there. Then it's 4x squared. That's the next biggest stretch. 4 is not quite as big as 5. And then we have 0.7 is actually compressed. So he's squished down, not pulled taller. Okay, so let's see. And I should say, okay, so this guy is upside down, but he's stretched the tallest. I'm going to draw a picture. So he's not stretched quite as much, even though he's a smiley. And this guy's more like this, like a big fatso pushed down. All right, let's turn that over. Next one says, use the given graphs to find the roots of the following quadratic equations. Now we've done this. These are really cool. The root, the solution, the zero is all the same thing. And it's right there where it crosses the x-axis. So there's one root at 3. And then where else does it cross the x-axis? At 1. So those are roots. They're called the zeros. They're called the x-intercepts, the solutions. Let's look at this one. I see he crosses at -1 and -3. Those are my roots. Okay, so that's a pretty visual problem. You're just eyeballing. Where is that x-intercept? Next, the quadratic equation graph has roots between integers. Name the consecutive integers which the roots lie between. Okay, so it's not right out a perfect number. These guys landed on a perfect number, whole number. These ones do not. So this is where you have to say between, and then let's see, this is -1, -2, and -3. It's between -2 and -3. And there's a second one here, which is between 0 and 1. Okay, I got a little low. Anyway, you're just eyeballing it again. Give the whole numbers on either side of the x-intercept. All right, the last ones you're actually going to factor to solve these quadratics. So instead of eyeballing the graph to see where those solutions are, we're going to use what we know about factoring. And the first one doesn't have a middle term, right? Ax squared, there's no like bx in there plus c. So what I noticed first about that is this is a perfect square and this is a perfect square. What I can do is put the perfect squares on opposite sides of the equal sign. X squared equals 100. That wouldn't really work if this had been a plus 100, because when I move him to the other side, it would be a -100. And then we get imaginary. We haven't gotten to imaginary numbers yet. But if there's a -100, he moves over to the other side as positive. So this one works out great. Take the square root of both sides, and x equals, now don't forget that there are actually two answers here, right? There's a plus and there's a -10. So not just one answer. And that's something you want to think about. Make sure you're really hitting that +10 and -10. That means if we graphed this, he would cross the x-axis at +10 and at -10. So he's got two x-intercepts. Okay, let's look at the next one. X squared plus 6x plus 7. All right, to factor that, we need it to be equal to 0. Do you remember that lesson when we talked about that? Let's get the 7 to the other side. X squared plus 6x minus 7 equals 0. Now we can go ahead and find roots or solutions or zeros. Let's see. Two numbers multiplied -7, and when you add them, it's 6. So how about we do 7 and -1? Sound good? Okay. X plus 7, x minus 1. So we factored it, but now we have to actually solve it. So we're taking that extra step where we need to actually say, what is x equal to? And we talked about the 0 property. If we multiply these together, it equals 0, which means one of those two has to be 0. That's the only way to make a 0 when you multiply. So let's, oops, I don't even need the parentheses. We're going to pull it and say, if this one was equal to 0, then what's x? -7. And if this one is the 0, what's x? 1. Now we have our two solutions and we're actually done. So you have to get all the way to that point where it says, what is x equal to? Last one. Okay, it's equal to 0 and it's a quadratic. So what we want to do, I would do a diamond, but since there is an a value, remember those, we have to take that extra step. So the top is a times c, -10. And then the bottom is still b. What two numbers do that? How about 5 and -2? That should work. Now, when we put this kind back in, we have to do the grouping. So instead of putting plus 3x, we're going to put these two factors back in. Plus 5x minus 2. Together, those are 3x. So we didn't change it. It's still equal to what it was originally. We just wrote it a little different. And then we do our grouping. What comes out of there? X, 2x plus 5. Here we want to pull that -1, so we've got 2x plus 5. And then let's finish it up. 2x plus 5 and x minus 1. We factored it, but we got to finish. Don't forget, finish the job. So if this one's 0, 2x plus 5 equals 0, we'll move him. 2x equals -5. Divide by 2. Divide by 2. So x is -5/2 for one of them. Let's take our other one. Add 1, x equals 1. So I'm going to put the other one here, -5/2. Those are our two solutions for the last one. Okay, if you feel confident, you got those solid, great. If you don't, you might want to try printing out a new one or trying those problems again in the review so that you are ready for the test. Good luck.